Hello students, this is the first set of notes in the astronomy unit. This will be page 13 of your digital science notebook. For the title of these notes, please write Astronomy Part 1, The Universe. Write the title at the top of the page. Throughout this presentation, you should write down everything that is in orange text. At the end of the video, there will be a catch-all page with all of the notes together. Remember, you can pause the video at any time. This video is available on my website, btrachy.home.blog. Astronomy Part 1, The Universe. So that's the title again. The universe is everything contained in all of outer space. The universe is huge. Using SI units, the Earth would be 880, I believe that's septillion kilometers in diameter. Very, very big. So outer space is so big, we use special units called light years to measure it. Light years are used to measure extremely long distances. The universe is 93 billion light years in diameter. So here's the deal with light years. Light moves very quickly. The speed of light is about 300 million meters per second. A light year is the distance you would travel if you spent one whole year traveling at the speed of light. The next closest star to us is Alpha Centauri, 4.3 light years away. If Alpha Centauri were to explode in a supernova, we would find out 4.3 years later, because the light from the explosion would take that long to reach Earth, even though it's moving very quickly. Could we ever travel to Alpha Centauri, our nearest neighbor solar system? At current spacecraft technology, it would take thousands of years to reach this nearest neighbor. The origin of the universe. The best theory for the origin of the universe is the Big Bang Theory. The Big Bang Theory states that the universe began in a very hot, dense state that expanded rapidly 13.8 billion years ago. The best evidence for the Big Bang is the observable fact that the universe is still expanding. Any light that is moving away from the point of observation will exhibit a shift towards the red side of the visible spectrum. This is called redshift. Any light that is moving towards the point of observation will exhibit a shift towards the blue side of the visible spectrum, and that's called blue shift. Using sophisticated technology like the Hubble Space Telescope, scientists have documented that all galaxies exhibit redshift and are therefore moving away from us because the universe is expanding. The evidence that supports the universe still expanding is redshift. And this is an image showing that. Galaxies are collections of hundreds of billions of stars. There are three types of galaxies: spiral, elliptical, and irregular. So a galaxy is a huge amount of stars, but there are many, many, many galaxies in the universe. The universe is all the galaxies. So compared to the universe, a galaxy is smaller. Our solar system is located in the Milky Way galaxy, which is a spiral galaxy. But how do we know? Is this a real picture of the Milky Way galaxy? No, it's not. There are real pictures of galaxies, and this might be a real picture of a galaxy, but nobody, no person, no camera, no human-made object has been outside of the Milky Way, which would be required to take a picture like this from a distance. So we are inside the Milky Way, and we'll always be inside the Milky Way, so we'll never see it from the outside. But we do have evidence of its shape. Part of that evidence is the way that stars in the Milky Way cluster in a line across the night sky. A spiral galaxy is kind of flat, and we are in a part of the galaxy that is the flat kind of spiraling side of the galaxy. And the cluster of stars that you see in the center of the sky there is the other stars in the same part of the Milky Way galaxy where we reside. Funny anecdote about this is that one time in Los Angeles, the power went out, and you could see the Milky Way galaxy for the first time in decades or maybe 100 years, um, because of all the light pollution in a big city. And people called the fire department because they thought there was a fire, but they were really just looking at the Milky Way. The origin of the solar system. So we talked about the origin of the universe. Now we're talking about the origin of just the solar system, the sun and the planets. The best theory for the origin of the solar system and all solar systems is the solar nebula theory. A nebula is a space cloud of dust and gas, and the theory states that all solar systems form when a nebula condenses. That means like collapses in on itself. So here is a diagram of the life cycle of a star. We'll draw this later. And there's two different pathways. One's for normal sized stars like our sun, and the other pathway is for larger stars. So star life cycles can take two different paths depending on how big the star is. As a star goes through its life cycle, its brightness and temperature changes. We track those changes using something called the HR diagram, or the Hertzsprung-Russell diagram. And here it is. It's got luminosity or brightness on the y-axis, brighter at the top, dimmer at the bottom, and then it's got temperature in Kelvin on the x-axis, with the highest temperatures to the left and the lowest temperatures to the right, which is sort of unusual for looking at graphs. So every star can be plotted on the HR diagram based on its current temperature and brightness. And over the course of billions of years, these individual stars also move along the diagram. Brightness, which is also called absolute magnitude or luminosity, is shown on the y-axis. Higher the star is on the diagram, the brighter it is. Temperature is on the x-axis, but it's backwards, like I said, highest temperatures on the left. So white dwarfs, as you can see, are super hot. And red supergiants are a little cooler than blue giants. So depending on where the star is on the diagram, it could be hot and bright or hot and dim, cool and dim or cool and bright, and our sun is right in the middle. Our sun is a run-of-the-mill average star. It's also on something called the main sequence. The main sequence is the diagonal line of stars along the middle. So our sun is an average star on the main sequence. Our sun is currently a main sequence star, but in approximately 5 billion years, it will run out of hydrogen fuel and become a red giant. Ultimately, it is destined to become a white dwarf, billions of years in the future. So all elements in the universe are produced inside of stars. Everything on our planet, everything inside of you, uh, every part of every planet was once inside of a star. Most stars are using fusion to turn hydrogen into helium. Remember, fusion is combining two atoms together. When they run out of hydrogen fuel, they start using the helium to fuse even larger elements like iron and nickel. Every element that can be found on Earth was once inside of a star. This is the first ever picture taken of a black hole. Black holes are a great amount of matter packed into a very small area. The result is a gravitational field so strong that nothing, not even light, can escape. Black holes are left behind when a very big star dies, and supermassive black holes are predicted to exist at the center of most galaxies. So here is all the notes that you were supposed to grab from this video slash presentation. And so you can pause it here and catch anything that you missed. And here's a handwritten version that is probably quite a bit harder to read, but just to show you how I organize it on the page. And that's it.